Hello and welcome to the Learn to Code Academy. This video is going to be the first in a new series, 2D video games development. So in this particular course, what we're going to cover is a range of topics to do with a software development approach to designing video games. So what exactly are we going to be touching on? There's going to be 3 units that this course is broken down into. Fundamental 2D video game design, Unit 1. Unit 2, algorithmic design and audio programming. Unit 3, let's play programming and non-linear algorithms. So it sort of increments in complexity as we go along. So what does Unit 1 have to offer? So what we're going to do is firstly look at an overview of video games and software development, fundamental patterns, the update function, rendering sprites onto a UI, input parsing, events, and compression techniques. So we're just gonna have like a kind of brief introduction into the realms of video games design and with Unit 1. But Unit 2 takes things a little bit of a step further with a look at algorithmic paradigms, movement algorithms, parallax, line functions, and AI, cameras, game mechanic design, creating responsive NPC actions, serialization and save state, compression of linear patterns and their uses, and an intro to MIDI and sound design. And the final unit is going to be focusing on net play programming and linear/non-linear algorithms. So we're going to look at LAN programming, P2P versus client server, a look at AI algorithms for dynamic game mechanics, and utilizing linear and non-linear functions for physics. So let's get straight into the course of Unit 1. This particular video is going to go through some fundamental concepts at the beginning of 2D video games design, and in this particular, should I say, course, we're not going to stick necessarily to just one particular programming language. However, the base language and platform that I choose for this course is going to be .NET Standard C#, utilizing Visual Studio. The front end will be powered by WPF, Windows Presentation Foundation mainly, but not exclusive to necessarily. And there are reasons for this, but I'm not going to go into that such right now. But let's get straight into the video, and as we go, things will definitely unfold. So I suppose the first question that may come to your mind as a developer, starting out, is what is a video game? Even as a player, how can one define a gaming experience? And the straightforward answer may be a virtual interactive experience that utilizes inputs and outputs with particular focus around feedback, and that's a very good response. Now, what are the attributes of a game? It's important to consider what the player expects from a video gaming experience and what are the fundamental patterns and standards that we can follow in order to guarantee that our game adheres to a certain feel, a certain form, without coming across as something that is flippant, if that makes sense. A possible concept we can consider for games is a risk versus reward sort of concept, giving the player the chance to benefit by additional achievements or kudos for playing in a certain way. So, depending on the context that an achievement is presented, excitement and hype can be generated, which induces signals in the human brain, which leads to the excretion of chemicals that imply sensations of pleasure. What this means is, in terms of how you design your video game, you could take advantage of the fact that human beings are quite fundamentally emotional creatures, and when we as human beings are exposed to scenarios that induce excitement and hype, there are chemicals in our brains that sort of induce these sensations of pleasure. And with video games, depending on how you present an action, you might do, just like in the screenshot in this particular video game, Tatsunoko vs Capcom, you may present, you may try and do some kind of super combo or hyper attack, and the screen will flash, you'll see like an energy beam coming out, everything's hype. That is something you can use to your advantage if you understand as a developer and a designer how to use it well. Because if you use hype and lights and flashing all over the place, every single moment of the game, it will become the standard. You got to set out the times, you got to set out the way to go about this. It's risk versus reward. You play in a certain way, you're rewarded in a certain way for your actions. So we've determined that video games usually leverage from a concept of risk versus reward. Games tend to induce excitement when an achievement is met. At a high level, we could link this phenomena with the release of dopamine in the brain. Therefore, we could argue that visuals matter because they are a determining factor to convey emotion to the player. So there's the ongoing, debate. Do graphics matter to a video game? I believe the kind of the greater answer is yes, because at the end of the day, firstly, you can't appreciate a game without visuals. But at the same time, the way you convey the visual information to your players is very important. And I'm not necessarily talking about pure visual fidelity itself, raw graphics, but the way that the graphics complement the story really makes a difference. Let me give an example. You may have a sort of, let's go to one end of the spectrum. So a child's game, a game designed for a younger audience. You may opt to go for maybe a cel-shaded style 3D action platformer because it doesn't need much of a story. The visual information is conveyed through simplistic style graphics that kind of resemble cartoons if it's cel-shaded, and it's simple. It's easy for a young audience to understand. But let's say, for example, you want to appeal to a more of a niche of a more mature demographic in age. Very well. So in that case, what you may opt for is a more realistic approach, opting for photorealism in the visuals, and maybe a focus on, say, action, depending on the niche you're going for. Maybe there's a romantic side to the story mode. All these things matter, and in a sense, they all convey visuals because the visuals are linked to the story. All of the information is conveyed through the visuals, including the more intangible aspects such as emotion and story. So moving on, what are we interested in as to video games design with all of that considered? We're interested in technical proficiency, programming skills, ID experience, etc., good sense for games design, and intuition and awareness of the visuals. So firstly, let's focus on technical proficiency, programming skills, ID experience, etc. Approaches to designing a game. You can consider when approached with the task of designing a game at any capacity to use off-the-shelf solutions such as a video games engine. Unity is a great one. Unreal Engine is another industry standard, versus building a custom framework. Building a custom framework entails writing, dedicated code for a particular game, and this game is tightly coupled to the system which runs it. So it may not necessarily be an engine in and of itself, but the framework itself is coupled with the gaming experience. So there's kind of a closer relationship between the back end and the game itself at runtime. Programming language to script functionality is another technical consideration. Excuse me. And the target end platform. So, porting games, is it going to be on PC? Is it going to be on a handheld console, mobile, etc.? So for this course, as I said at the beginning, I'll be focusing on utilizing .NET Standard C# for the backend. And so to follow this course, you don't necessarily need the same IDE, nor access to the same programming language. The skills are transposable across platforms. However, you can download Visual Studio 2017, if I'm not mistaken, unless the more recent build is available. But nevertheless, the community edition of Visual Studio you can download for free on Microsoft's website. Excuse me. So again, my reasoning for utilizing .NET Standard C# on Visual Studio, in particular with the front end being Windows Presentation Foundation, is the fact that I can expose the fundamental concepts of video game design from a software development point of view without sort of relying on the leverage of an engine. And what this means is that you will learn more at the core, at the lower level, because you're not relying on, certain functionality to be presented for you. You have to write the functionality itself. A camera algorithm, we're not relying on the camera algorithm of XYZ engine. We're going to be looking at that in a later unit in a little bit more depth, if not in this unit. So that's my reasoning there. It's more to teach the fundamental concepts which you can transpose for your own video games development endeavors. So without much further ado, let's get started. Unit 1, Fundamental 2D Video Game Design. We're going to start off with, or should I say, now that we've covered the first point, we're going to go to the second point, fundamental patterns, the update function. So let's get straight into this. So, with the way that modern games are now, there are a lot of things that happen at one segment of time. We can definitely agree that games over time have definitely increased in complexity. These video games have systems in place that deal with contingencies concerning player inputs, feedback, and perhaps things such as external events. For example, getting some kind of in-game invite to a friend's online co-op room whilst you are midway into your own game session. Drawing from this concept, if we narrow down this scope to, just say a single-player gaming experience, we could propose that we would need some sort of excuse me. My throat's a little groggy. Anyway, update function. We would need some sort of update function to deal with the real-time scenarios presented at runtime of the game. So, what is an update function, you may be asking? An update function is this kind of concept of having a recurring functionality at every instance of runtime in your game. And what this allows for is a sort of guarantee that at every frame, every instance that your game is running, you can execute some kind of functionality based on some predicate, some kind of precondition being met. So let's give an example, which I will go into actually if I continue with the slide. We're going to look at an example from a conceptual video game project that I prepared. So in this particular example, you may not be able to see it very well because I'm not sure how the capture software is getting this contrast. It may be a little bit tough to see, but in any case, we have here a threading dispatcher timer called main clock, which has been instantiated as a field in where you would place your fields depending on how you structure your code. And in the constructor of this particular example, we are setting the properties of our main clock to 00001 in terms of the time span. And if you're familiar with the time span class, you will know that this adheres to the millisecond. So every 1 millisecond, the main clock is going to tick. And once it ticks, I've put here that it will call the update function. So in effect, what I've created is my own custom update function, because this function, update, if I can find my mouse pointer, update will occur at every tick of the main clock, which has been set to 1 millisecond. So in this case, it has to do. Well, if we look here at FPS counter, what it does is it sets a precondition. If FPS count is equal to 59, then this FPS count is equal to 0, and I update a block of text. Otherwise, I increment FPS count, and then I update a block of text. So what we see here is that we're updating a counter for every frame of our virtual main clock, and that is taken care of by the update function. So for this particular video, this will be the next thing that we're looking at. I'm going to split it into two so that the next half of this particular introductory course will be the last 3 segments. So rendering sprites onto a UI. There are different ways this can be approached depending on the platform of choice and the rendering engine or frameworks being utilized. Visual Studio 2017 Community Edition gives us access to the native GDI graphics library, which allows for reasonably simple rendering of 2D graphics and animations. Developers can also download DirectX-based wrappers such as SlimDX on the NuGet store for more complex graphical and animated computations. So what's really cool about utilizing Visual Studio .NET Standard C# is the fact that you have access to these DirectX wrappers, in particular SlimDX. I think there's one also called goodness, I can't remember what it's called. Is it DirectDX? Something else. It's not. There's another one, but I think it's deprecated. There used to be a particular. There are frameworks you can get a hold of, such as Monogame framework, and which is a sort of successor in a way to the XNA framework, which are basically a set of libraries, a set of functionalities that abstract video games design within the Visual Studio environment. So you have a set of tools available to you to help abstract the video games development process, utilizing Visual Studio and C# in order to create your own custom frameworks for developing games. And if you ask me my honest opinion, I believe that utilizing a framework such as Monogame is probably on balance one of the best approaches to developing a custom game, like, you know, a really customized, detailed experience. Because when you look at engines that are there, you are limited to their tool sets, you are limited to what they can offer. You can be creative, but when you have to think about, you know, the physics itself, you know, when you have to think about the image rendering, when you have to think about making everything work together, it pushes you as a developer, and it also sort of encourages a unique style to your game. Whereas using an engine somewhat promotes, should I say, a kind of similar style between different projects. You tend to see a particular game and you think, oh, that looks like a Engine X game, or you look at another game that looks like an Engine Y game. But I just see that if you kind of make things from scratch, you have your own identity with the game. It doesn't really get that label of Engine X or Engine Y. Anyway, so for this part of the course, we'll be focusing on GDI, as it is simple to use and conveys rendering concepts that can be applied across other libraries. Visual Studio also offers a XAML editor for the GUI. We will utilize this, but we will keep dependence on the drag and drop element of the UI design to a bare minimum whilst focusing on programmatically rendering assets at runtime. Please consider the following scenario. So over here, in case it's kind of hard to see because of the video capture, I have two blocks supposedly behind, or should I say in front, right? Slide behavioral graph. This way, assets can be rendered in real time without the burden of being so tightly coupled to the XAML controls themselves. So I actually have the project. I have the project this came from, and if there's time, I will place it in this video to some capacity so you can have a look at how those placeholder assets, those placeholder squares, actually just, as the name implies, they just hold the place for the actual assets, which creates a decoupling effect, which means that your final sprites don't have to necessarily be the same placeholders or coupled to the placeholder control elements that are on the screen. And if you're interested, if you're utilizing C#.NET Standard, you can have a look at some of the source code for loading the stage. And I would argue, more importantly, for those utilizing C#, you won't be able to see everything actually. The only thing cropped out is the return statement at the bottom and the declaration of the method at the top. But what you should be able to see is the functionality that what I'm doing here is just instantiating a particular image onto the screen via bitmap, and this is the stage background. And this is how I would approach it, utilizing, if I'm particularly utilizing GDI in Visual Studio 2017 Community Edition. So is that the... Okay, so we're going to leave it there for this particular part of the video. In the next part, we're going to be looking at input parsing, events, and compression techniques.